This is the brand new Carvera Air metal and carbon fiber cutting CNC machine, and I have no idea how to use it. Let's find out together. Before we can mill awesome RC car parts out of 7075 aluminum or forged carbon fiber, we need to go over some basics. In its simplest form, a mill takes some sort of cutter, usually spins it, and cuts material away from something like this blank to reveal the part that's inside that you actually want. In many ways, a mill is very similar to a 3D printer in that it has a mechanism that moves ahead in 3 axes. The difference is with a 3D printer, you're actually adding material to create the part that you want, and in a mill, you're removing material. Machining mills and their cousin, the lathe, have been around a very long time. The first mills were created in the late 1700s and were designed for boring holes in cannon barrels. But the first true mill was designed by Eli Whitney in the early 1800s, unsurprisingly again, to create weapons. Over the years, mills have been powered by a number of different methods, including human power, horsepower, steam power, and most recently electrical power. The mill and its cousin, the lathe, were largely responsible for the Industrial Revolution because they allowed parts that were the same to be made over and over again. Previous to the development of these types of machines, everything was made by hand, and it was all hand-fitted, so there was no standardization on parts. The reason why this gear will fit on any 1/10 scale Traxxas differential that it's designed for is that it's made precisely by a machine like a mill and or a lathe. But this is not a manual mill. This is a CNC or computer numerical control mill, and that means you get to program in what you want, and it cuts it out for you automatically. This has a very similar mechanism to a 3D printer, but there are also a lot of differences. And this particular CNC mill has a bunch of features that should make it a lot easier to use than most other mills. There are 2 main things you need when cutting with a mill. That's power and rigidity. Power comes from whatever is spinning this tool, and rigidity comes from the frame and mechanism that actually holds everything in place and allows it to move. You need power because this cutter is actually shearing off pieces of the material, and you need rigidity because as it cuts, it's going to try to push away from the material, and if it's not held rigidly in place, that's all it's going to do, and you're not going to cut the material, you're just going to end up with a mess. Whereas this CNC mill isn't particularly powerful, its motor is only 200 watts. It is very stiff. You can see we've got big rails back here that hold the motor and gantry in place, and this is all one giant thick piece of die-cast aluminum. Flipping it on its back, we can see this giant chunky piece of aluminum that supports the entire structure. This creates a ton of rigidity. We can also see that this thing runs on ball screws. I'll tell you about ball screws in just a minute, and everything feels really, really beefy under here. That single piece of aluminum extends all the way up on both sides, and that's what supports this gantry, which supports the actual cutting head. And that should be what makes this thing capable of cutting brass, aluminum, and yes, even steel. The design of this does look similar to something like this, which is a CNC wood router, but it's that one-piece chassis, which resembles something more like a professional mill. That should mean we can make some really nice, precise RC car parts with this thing. This particular mill comes with a pretty intimidating set of tools and accessories, but it also comes with this examples guide, and this guide gives you very detailed instructions on how to do a few projects that are going to help us get familiarized with exactly how this mill works. But it also comes with this giant box full of sample materials, so enough talking, let's go make some chips, and then later, we're going to make some RC car parts. The first thing the example guide wants us to do is install this MDF spoil board and this corner bracket. Next, it wants us to take one of these single-sided PCBs and 4 of the edge clamps and go ahead and get it clamped down. This probably doesn't have to be exact as long as it's held down well and the clamps don't get in the way of the cutting. The next step in the book is to get your bits prepared, get the software installed, which we've already done here, and then all we're going to do is open up the files that they tell you to open up, select it on here, install the correct bit, which as you can see here installs using a quick change coupling. That's one of the great advantages of this CNC machine. I've also hooked up my dust extraction vacuum cleaner. This has built-in dust extraction, but you do need to supply your own vacuum cleaner. This is a Stealth Sonic by DeWalt and has a HEPA filter in it. That's going to be really important for when we cut that carbon fiber here in just a few minutes. But for now, let's get these files loaded up, set it up exactly like they tell us to, and see if this thing works. Now, obviously, the first part we're making here is a circuit board, and after cutting out this part of the traces, the next step is to give the board a little bit of a polish, and then we're actually going to apply some solder mask to it. The book does warn not to use too much solder mask, so we're just going to use a little bit at a time here and see if that's enough. And I'm pretty sure we already have enough here. And now we just need to cure it with the included UV cure lamp. This part of the kit's not included in the actual base CNC mill. It's included in the PCB fabrication kit, but you can do these projects without this part of the kit. You just wouldn't do the solder mask. All right, now that's all solidified. Now we just need to use the solder mask removal tool to clean this up and then finish up the surface and finally cut it out. With that, we've created a circuit board. This thing actually looks really good. The edges are very smooth. All the holes appear to be where they're supposed to be. And now we just need to populate it. If you don't feel like soldering, Makera does give you an already populated board, but I want to make sure that the one we created actually works. And don't worry, we'll be making some real chips very soon. We're going to be using this board as a template for our own, so I just want to make sure this thing works. It has a little touch control right here, and yep, it lights up just fine. So now all we have to do is put all of these bits on here where they are on here. Since we're going to be soldering on this side, the parts are actually going to go through on this side. Some of these parts don't have a polarity, such as these resistors, but some of them, such as this small electrolytic capacitor and these LEDs do. So if you're going to be doing this, make sure you pay attention to the orientation on this board. If you've never done electronic soldering, it's pretty straightforward, especially on a single side board like this. I just push this part through and I'm going to spread the legs out to hold the part in place so I can put more parts on and solder them all at once. There's all the long leaded parts on there. Make sure you double check the orientation of everything because you're only going to get one shot at this to not blow something up. There we go. Now, I'm not an electronic soldering expert, but I think that looks passable, and I only gave myself 1/3 degree burn doing it. Let's see if this works. Plug this in and touch the little touch spot. Look at that, they light up. That's pretty satisfying. Of course, like I said, if you do this and it doesn't work out, you do have this board to fall back on, which is really handy. But now it's time to do some real milling with this thick ABS plate. And again, we're just gonna follow these instructions in the manual for the setup. I did deviate from this clamping strategy a little bit because I couldn't get these two screws to hold on. But other than that, we just make sure we have our bits ready, load up the code, set everything up as required, and hit go. All right, so now we can see how this is starting to come together, and this looks really cool. The last thing we need to do is mill out the touch switch, and just like our soon-to-come shock tower, the touch switch is made out of aluminum, so things are about to get serious. While that aluminum's cutting, I can't help but get a quick sneak preview of what this is going to look like. So let's just stack this together and hold it in place. And I think we can just touch the wire here on the side. And there we go, guys. That looks really cool. And you know what? They actually gave me a spare piece of acrylic. So I'm going to go ahead and do a giveaway. Put any comment down in the comment section. And if you win, I'm going to cut out whatever you want on this other piece of acrylic and then send this cool little lamp to you. And there we go. This machine definitely cuts aluminum very nicely. Let's get this thing put together. I'm definitely appreciating the features that this mill has. The automatic tool height setting, automatic probing, built-in chip evacuation, and enclosure really make milling a pretty pleasant process. With a regular mill, it takes quite a bit of time to switch tools, and with this one, it takes about 10 seconds. What we've done so far, though, is kind of the easy part, and when we start making RC car parts, things are going to get a lot more difficult. But before we do that, I've got one more feature to show you on this mill that you may have never seen before. Let's see if this works. And there we go. That looks really cool. Again, make sure you drop a comment for a chance to win a custom version of this with whatever you want on it, and then make sure you turn on the bell to get notified because I'll be announcing the winner in a community post. Now, the last feature we have to look at is probably one that won't be used a ton, but it's definitely the coolest, and that's this fourth axis. As I've shown you, the CNC machine, like a 3D printer, normally runs on 3 axes, X, Y, and Z. This adds a fourth rotary axis to that. And this is going to allow us to make things that we normally wouldn't be able to make on the CNC machine. So how does this work? Well, it has a stepper motor here in the back, just like the other axes, but then it has a really cool thing called a harmonic drive here in the middle. This harmonic drive is really weird, and it actually uses a flexible gear to create a gear reduction without any backlash. As you can see here, if I wiggle this chuck, it doesn't move at all. Normally in any kind of mechanical system where two parts are rubbing past each other, such as in gears or in threads, you have to have some space between those parts, otherwise you're going to have a lot of friction and excessive wear. That's a problem in a machine like this because it reduces precision and rigidity. The main machine gets around this using something called a ball screw. Essentially, a ball screw has a set of recirculating balls that ride on the screw, and those balls in the screw create a rolling surface instead of a sliding surface, and that allows them to have essentially zero backlash. This harmonic harmonic drive uses a flexible gear that also creates that rolling motion instead of having a sliding motion, and it allows this to also basically have zero backlash. As far as I know, this is the only small fourth axis that uses a harmonic drive, and it should make this a lot more precise than something that doesn't. Makera does provide some sample material for this and a sample project, so let's get this set up and see what it can do. Installing this is very easy. We just take our corner bracket off, mount it up as shown in the instructions, then we're going to install our material, load up the file, and watch the magic happen. While that's cutting, let's talk about making something we can actually use, and to do that, we're going to make a stronger version of the stock shock tower for the new V6 Notorious out of 7075 aluminum. In order to design something like this, we need to know what parts of this original piece are actually important, and that includes things that interface with other parts, such as this feature right here that interfaces with the bulkhead, the screw holes that actually screw into the bulkhead, these screw holes up here for the shock mounts, the body mounts, and for the upper front hinge pins. Things that aren't as important are designs like this scallop right here, and these holes here in the middle, at least on the front shock tower. There are a lot of ways you can go about designing something like this. What I'm going to do is go ahead and take a picture of it, import that into Fusion 360, calibrate the picture for size by measuring something on the original part, and then I'm just going to start tracing out all the important details. This isn't the only way you could design this. You could take the original and start measuring from hole to hole and creating the duplicate that way. That would be a more accurate way of doing it, but this is a fast way of getting fairly close, and we really only need to get fairly close because now we can take this design over to the laser cutter and cut it out of paper. This takes about 10 seconds to do, and then you can take this paper design and test it to see how it fits. This one isn't quite right. You can see it's a little bit too big, so we'll make some adjustments, print it out again, make some more adjustments, print it out again, and now we're starting to get pretty close. Once we get close, we can go ahead and switch to our 3D printer and print out a thicker version that'll actually allow us to screw into the parts that we're going to be interfacing with and see how that fits. Keep in mind though that the 3D printer isn't perfect. These paper cutouts will actually be a little bit more accurate than the 3D printer is. As you can see here, what I've done is added quite a bit of meat here on the edges, and I took these holes out of the middle. That's going to make this a lot stronger. Now we have our model, but we're not quite ready to cut this out of metal yet because we need to tell the CNC machine how to cut it out. We're going to do that using a system known as CAM, or computer aided manufacturing. Basically what I'm going to do is take the model and create tool paths to cut out each one of the features. First, we're going to thin the stock down to the appropriate thickness. In this case, it's 5 millimeters. Then we're going to switch bits and do the engraving, switch the bits back, drill our holes, and then cut out the outside. This can be a pretty intimidating process because there are a lot of options in here, but there are also some really good tutorial videos on YouTube you can use. Makera also has their own CAM software, which is a fairly simplified version of what you see here, and it might be best to start with their software. All right, guys, before we cut this out of expensive aluminum, this stock is more expensive than you might expect it to be. Let's cut it out of a piece of wood to make sure everything works, but before we do that, it looks like our fourth axis job is done. Let's check it out. And to be honest, guys, I'm kind of shocked at the level of detail here. This isn't absolutely perfect. You can see a little bit of artifacting here at the top, but if you look down in the ears here at the eyes, this is a pretty small model. You can see it's smaller than my thumb, and there is a ton of detail here. Look at that necklace and the hair detail on the back. This is really, really impressive and definitely shows the amount of precision that you can get out of this machine. But now I want to cut my parts out on the machine, so let's get to cutting. And yeah, that looks pretty good. It fits on the bulkhead just fine. You can see the engraving looks great. Obviously there was some tear out here, but this was just some cheap plywood. And overall, I'm pretty impressed with the finish. So now I guess it's time to move to metal. Obviously this cutting is sped up, but one of the nice things about a machine like this is, just like with a 3D printer, you don't really need to babysit it all the time. It's a little bit more demanding than the 3D printer because if something goes wrong, it could go catastrophically wrong. But it seems like once you're familiar with the programming, you should be able to know when you can leave it and when you shouldn't leave it. And you can program in stops between steps so you can check and make sure everything's going okay. Of course, I'm sure they recommend you never leave this thing unattended, but they say the same thing about 3D printers. And there we go, guys. This thing looks absolutely gorgeous. It's pretty smooth. I can feel a little bit of the machining marks. The engraving came out well. All the chamfers look really, really good. The edges look nice. We do have some artifacts where the tabs were, but there's really no way to get around that other than using a different way to hold this down. But of course, looking nice means nothing if it doesn't fit. Let's get this on the truck. Because I knew we were going to be using these big beefy M2C standoffs, I went ahead and made these upper holes 5 millimeters so we don't have to drill them out. That's really nice. Obviously my shock tower isn't quite as thick as the M2C shock tower, but I did add a little extra girth here on the edges, so hopefully that'll help make up for it and this thing will still be nice and strong. I present to you the world's first Do RC fully custom 7075 aluminum shock tower. I don't think there's any doubt that it looks good, but will it bash well? Will it hold up to some thrashing? Let's go find out. Man, this new Notorious is a lot of fun, and the custom shock tower held up really well. Designing, manufacturing, and then bashing this was really rewarding. Of course, you could just buy an upgrade from M2C for this shock tower, and this is probably going to be superior. However, the last thing we're going to be making is something you can't buy, and that's rear mudguards for this awesome V4 Arrma Vortex. And we're going to be making it out of this beautiful piece of forged carbon fiber. I want to stress, if you're cutting carbon fiber, you need to make sure you have a good dust extraction system. The vacuum cleaner I'm using has both a fine dust particulate bag filter and a HEPA filter, and that's about the minimum you want because you don't want those carbon fiber particles in your lungs. This looks absolutely amazing. The forged carbon fiber with the Arrma logo on here looks really nice. Let's see what it looks like on the truck. And there we go, guys. I think it looks absolutely fantastic, but is it going to perform well? Let me get the other side on and let's go find out. Just like the shock tower, these mudguards held up really well, and I think they'll definitely do the job. So the real question is, who is the CNC machine for? If you're the kind of person that just wants to upgrade your car, most upgrades can be purchased, and they can be purchased for a lot less money than the cost of this machine. But if you're the kind of person that's attracted to taking raw material, making your own designs, and having a custom machine that nobody else has, this could be a really intriguing opportunity. And there are definitely more powerful CNC machines out there. By the way, this thing can cut steel and even titanium. As you can see here, it cuts them very slowly. This is only a 200-watt spindle, but it it does have the rigidity to do the job. And again, being a CNC machine, it's not like you have to stand there and actually run it the entire time. That being said, this is an expensive machine. There is a lot of learning you have to do in order to use it. It does have some really nice convenience features, the enclosure, the chip evacuation, automatic tool setting, automatic material probing, the integrated software, and just general ease of use definitely makes it a lot more user-friendly than a lot of other CNC machines, but it's not going to be quite as easy as something like today's modern 3D printers. It is, however, extremely versatile, from making really detailed models to creating things like fully functional circuit boards and machining from engineering-grade materials. You can do things on a CNC machine that you just can't do with a 3D printer. Keeping in mind my limited experience with CNC machines, I think the Carvera Air is a really nice machine, and it goes a long way towards bringing CNC machining closer to that 3D printing experience, though again, it's not quite there yet. That being said, I'd love to hear your thoughts on CNC machining in this hobby. Do you think it represents the future of upgrading? I think for some people, it very well might. Make sure you comment and subscribe for a chance to win your own fully custom lamp, and I'll see you in one of these videos.